Yeah, so we're given like in a middle school mentoring program, a number of the sixth graders are paired with a ninth grade student as a buddy. No ninth graders assigned more than one sixth grade buddy. If 1/3 of all the ninth graders are paired with 2/5 of all the sixth graders, we want to know what fraction of the total number of sixth and ninth graders have a buddy. So this is an example of a question that deals with like ratios and like algebra, like equations and things like that. So notice that like we have a bunch of words here, but like in math, you don't want like word problems. Like, I mean, like words can be confusing sometimes. So you want to change all these words into math. So let's say you let n represent the number of ninth graders. And let's say you say s or something is equal to the number of sixth graders. So we're given that 1/3 of all the ninth graders are paired with 2/5 of all the sixth graders. That tells us that 1/3 of n, so 1/3 of all the ninth graders is 1/3 of n, must equal 2/5 of all the sixth graders, which is 2/5 s. So we want to know what fraction of the total number of sixth and ninth graders have a buddy. So if we were to kind of like multiply by 5 on both sides and multiply by 3 on both sides, then we would have 5n is equal to 6s. So notice that like the fraction that we want, right? It says what fraction of the total number of sixth and ninth graders have a buddy. So the total number of ninth and sixth graders, like as a whole, is going to be n plus s, right? Now, the number of ninth graders that have a buddy is going to be 1/3 of n, and the number of sixth graders that have a buddy is going to be 2/5 of s. So notice that like notice that I can now say that s from this equation, that when I divide by 6 on both sides, s is going to equal 5n over 6. So I can kind of substitute like this expression into these values of s just to remove them. So if I were to substitute these values, I would have 1/3 of n plus 2/5 times s. S is going to be equal to 5n over 6. And then I divide this by n plus s, so n plus 5n over 6. So now I can kind of simplify this. We can cancel off of 5 here, and you can cancel like here, like this is n over 3. So on the top, you have n over 3 plus n over 3, so it's 2n over 3. And on the bottom, you're going to have n plus 5n over 6, which is going to equal 11n over 6. So now conveniently the n's cancel, so we can kind of like remove these. So this is going to equal 2/3 divided by 11 over 6, which is times 6 over 11. So we can cancel off these a factor of 3. So 2 times 2 over 11, which would be 4 over 11. And that would like be choice B. And yeah. Yeah, okay. So the main idea, I guess, for this problem was we tried to like build some algebra equations out of these words, and we kind of like built some equations, and we found like this like ratio of numbers. And a lot of these times, like notice that this question like didn't allow us to actually solve for the values of n and s. We instead found a ratio in which the variables canceled out. So a lot of the times, like if they don't give you enough information, then usually like things will work out nicely. Like in this case, like the n's canceled out. So like it didn't actually matter like how many ninth grade students there were or how many sixth grade students there were. Like the ratio of that we wanted in this question like always remained constant and fixed. So